Alright, let's upgrade our spaceship with some serious firepower. First, you'll notice we've added new constants for our bullets. Bullet width is 5 pixels, bullet height is 15 pixels, and bullet speed is 10 pixels per frame. The bullets are small and fast, which makes them feel realistic and responsive. We've also added a bright yellow color for our bullets. Yellow works great because it stands out against the black space background and clearly shows the player's shots. Now we have 2 lists to manage: enemies for our asteroids and bullets for our projectiles. We also have a score variable that starts at 0. Managing multiple lists of game objects is a common pattern in game development, and you'll see this structure in many professional games. Let's examine our new shoot_bullet function. This function creates a new bullet positioned at the center top of our player. We calculate the bullet's X position by taking the player's center X coordinate and subtracting half the bullet width. This centers the bullet perfectly on our spaceship. The Y position starts at the player's top, so bullets appear to fire from the front of our ship. The update_bullets function moves all bullets upward by subtracting the bullet speed from their Y position. Just like with enemies, we remove bullets that go off-screen to keep our game running efficiently. Memory management like this is crucial in game development. Here's where things get really interesting. Our check_bullet_collision function. This function checks every bullet against every enemy to see if they collide. When a collision happens, we remove both the bullet and the enemy from their respective lists, and we increase the score by 1. The break statement is important here because it prevents errors when we modify lists during iteration. Our check_player_enemy_collision function remains the same as before, handling the game over condition when our player hits an asteroid. The draw_everything function now has much more to display. We draw the player, all enemies, all bullets, and our score. Notice how we're drawing the score in the top left corner using a font. The score display gives players immediate feedback on their performance, which is essential for engaging gameplay. Now, let's look at our enhanced game loop. The big addition is in our event handling section. We're now checking for KEYDOWN events, specifically the spacebar. When the player presses space, we call our shoot_bullet function. Using KEYDOWN instead of checking press keys means the player has to release and press the spacebar again to fire another bullet, preventing rapid-fire spam. In our update section, we now call update_bullets to move all our projectiles, and we call check_bullet_collision to handle shooting interactions. The collision detection happens every frame, ensuring responsive and accurate gameplay. Here's a crucial programming concept we're demonstrating: state management. Our game now has multiple interacting systems: player movement, enemy spawning and movement, bullet creation and movement, collision detection between different object types, and score tracking. Each system has its own responsibility, but they all work together to create the complete game experience. The collision detection we're using creates a satisfying cause and effect relationship. Player action, pressing spacebar, creates bullets. Bullets hitting enemies removes threats and increases score. This feedback loop is what makes games addictive and fun. Notice how our game over screen now displays the final score. This gives players a sense of achievement and encourages them to play again to beat their previous score. Score display and game over feedback are crucial elements of good game design. Try playing the game now, and you'll feel how much more engaging it is when you can fight back. The shooting mechanics add agency to the player experience. Instead of just avoiding problems, you can now solve them by shooting. One important thing to observe is how we handle multiple collision types. We have bullet-enemy collisions that remove both objects and increase score, and player-enemy collisions that end the game. Different collision types having different outcomes is a fundamental concept in game development. The scoring system we've implemented is simple but effective. Each destroyed asteroid gives 1 point. In more complex games, you might have different enemy types worth different points, bonus multipliers, or combo systems, but the basic principle remains the same. In our next tutorial, we're going to make our game look absolutely stunning. We'll add an animated star field background, enhance our visual effects, improve our user interface, and even implement increasing difficulty as your score gets higher. The gameplay will remain the same, but the visual polish will make it feel like a completely professional game. Fantastic job on completing Tutorial 3. You now have a fully functional space shooter with scoring. Try to beat your high score a few times and notice how the shooting mechanics make the game much more satisfying to play. Don't forget to like this video if you're enjoying the series, and I'll see you in the next tutorial where we make everything look absolutely amazing.